All right, guys, here is 7.5.2, or 7.5.1, sorry, partial fractions. This is another tool in our toolbox for figuring out integrals. Best way to do this is by examples. We're just going to do a couple examples here just to get us acclimated to this. So, for example, let's say I've got 2x plus 16 over x squared plus x minus 6 dx. All right, so we don't know this antiderivative. This is not a common one that we should just know. U sub would be maybe our first guess, where you'd say, okay, maybe u is x squared plus x minus 6, except when you take that's derivative, that's just 2x plus 1, not 2x plus 16. So my derivative wouldn't be substituted in. It wouldn't be integration by parts or tabular because I don't have the two things multiplied. So this is where we get into partial fractions. Partial fraction says to do this. We're going to take the fraction 2x plus 16 over x squared plus x minus 6. And I'm going to say, okay, this is going to equal two fractions. I don't know the numerator. That's just going to be a and b. But my denominator is x squared plus x minus 6 factored. Do you guys remember factored? That's, doing FOIL backwards. Where I'm going to ask myself, okay, what multiplies to negative 6 but adds up to 1, because it's 1x, right? So it multiplies to negative 6 but adds up to positive 1. Well, it's going to be a plus 3 and a minus 2. Right? Because 3 times negative 2 is negative 6. 3 plus negative 2 is 1. So that means I've got x plus 3 down here and x minus 2 under the b. Now, it doesn't, if you guys mix that up, it doesn't matter. You'll get the same answer at the end. Now the thing is, though, we need to figure out what a and b are. That means I've got to bring these fractions together. And to figure out the numerator, that means I need the whole common denominator. That means I'm actually doing a little bit of cross multiplying here. So I'm going to say, okay, the numerator 2x plus 16 actually equals a times x minus 2 plus b times x plus 3. And then I'm going to distribute. That's going to be ax minus 2a plus bx plus 3b. Now, everything with an x, I'm going to put together. That's ax plus bx. That's just going to be a plus bx. Everything without an x, I'm going to put together. So plus negative 2a plus 3b. Now, look back over here. This has to equal 2x plus 16. That means your a plus b, since that's in front of the x, the 2 is in front of the x. So that means a plus b equals x, equals 2. The negative 2a plus 3b is the number by itself, which is 16. So that equals 16. Now I've got to do some substitution to solve that. So I can say, okay, a equals 2 minus b. I'm going to subtract b here. I'm going to replace that 2 minus b in for the a in the other equation. So negative 2 times 2 minus b plus 3b equals 16. Okay, so that's negative 4 plus 2b plus 3b equals 16. I'm going to add the 4, so that's going to be 20 on this side. 2b plus 3b is 5b. Divide by 5, b equals 4. So b equals 4. Go back over here. That means this is 2 minus 4, so that means a equals negative 2. Got it? So above the x plus 3 is negative 2. Above the x minus 2 is going to be 4. So I've got, just to remind myself, negative 2 over x plus 3 plus 4 over x minus 2. Now I'm going to integrate. Well, this is easy to integrate. Negative 2 is just a number. The antiderivative of 1 over x, that's just going to be the natural log of x plus 3. Plus 4 times the natural log of x minus 2. I don't have any limits, so plus c. That is my answer. So what we've done is that we do partial fractions to help us break down these fractions into two easier integrals that we can actually do. Got it? Now, this works when the integral, the degree in the denominator is bigger than the degree in the numerator. Let's do another example. This is a little long. I know it's a little long, but it's actually not too bad. It's mostly knowing algebra over everything else. So let's try another one. Let's say I did we'll do 5x plus 14 over x squared plus, I don't know, 8x plus 7. So now let's take a look. Not going to be able to solve this with U sub. Not going to be able to do it with integration by parts. I'm going to do partial fractions. So what I'm going to do is try to figure out, okay, what is the factor of x squared plus 8x plus 7? That means what multiplies to 7 but adds up to 8. Well, that's very straightforward. That's just x plus 1 and x plus 7. This might be ugly because of the number 7. So I have a over x plus 1 plus b over x plus 7. And then we're going to cross multiply to get the numerator. So 5x plus 14 equals a times x plus 7 plus b times x plus 1. Distribute ax plus 7a plus bx plus just b. Everything with an x goes together, so that's going to be a plus bx. Everything without an x goes together, that's going to be just 7a plus b. All right, so now with the x, that's a plus b. Well, what has an x here? 5. So that means a plus b equals 5. That means 7a plus b equals 14. Okay, let's do some substitution. So what we can do is just say, and you can substitute anything you want. Let's say I do the other way. Let's say I said b equals 5 minus a. So now I'm going to plug it into the other thing for b. So that means that 7a plus b is 5 minus a equals 14. Okay, I'm going to subtract the 5. So 14 minus 5 is 9. 7a minus 1a is going to be 6a. So that means a is going to equal 9 divided by 6, which is going to be 3 halves. So plug that back over here. So b equals 5 minus 3 halves. I know how much you guys love your fractions. Common denominator should be 2, so change the 5. 5 times 2 is 10. 10 minus 3 is 7 halves. So that's our b. So 3 halves goes in over x plus 1. 7 halves go over x plus 7. So a was 3 halves over x plus 1 plus 7 halves over x plus 7. I'm going to put a dx, and then now I'm integrating. Again, 3 halves is just 3 halves. So I'm going to put that to the front. And then 1 over x plus 1, that antiderivative is the natural log of x plus 1. Plus 7/2, just bring it to the front. 1 over x plus 7, that antiderivative is the natural log of x plus 7. Remember, it's natural log because the degree of the x is just a 1 down there. And then plus c. And there we go. All right. What if I had something like this? Oops. X squared minus 9dx. Now, here's the deal. Look at my degrees. They're the same. I can't do partial fractions unless the degree in the denominator is bigger than the numerator. So if they're the same or the degree in the numerator is bigger, first thing you have to do is long division. That's why we went over long division yesterday. So I've got x squared plus, I'm going to put 0 x's plus 6, that's a spot there, divided by x squared minus 9. All right, x squared goes into x squared. How many times am I going to multiply x squared by x squared? Well, that's just once. Multiply that through, that becomes x squared minus 9 I'm going to subtract. That cancels out. 6 plus 9. And I get 15. So it becomes plus 15 over x squared minus 9. So now, what I'm really integrating is 1 dx, because my whole, plus the integral of 15 over x squared minus 9. Well, the 1 is easy. The antiderivative of 1 is just x. Here, I've got to do partial fractions again, where I got to do my a and b. So 15 over x squared minus 9 equals a over something plus b over something. Okay, well now let's factor. What factors x squared minus 9? Well, that's going to be x plus 3, x minus 3. Let's do our cross multiplying. So 15 over a times x minus 3 plus b times x plus 3. Ooh, I squeezed too far in. I'll move over again. So 15 equals, I've got ax minus 3a, plus bx plus 3b. All the x's go together. A plus bx. Everything without an x goes together, so that's negative 3a plus 3b. Now, do I have any x's here by plus 15? No. So that means that's 0 x's. So a plus b equals 0. The negative 3a plus 3b equals 15. So it's because it's 0 x's plus 15. So 0 plus negative 3a plus 3b is 15. All right, so I'm going to say a equals negative b. Plug that in here. So a is negative b times negative 3, that's going to be positive 3b plus 3b equals 15. That's 6b equals 15. So that means b equals 15 divided by 6. 3 goes into both of those, so 5 halves. So if b equals 5 halves, a is just the negative version of that, so a is negative 5 halves. So now when I come back over here to the top, this is negative 5 halves, b is positive 5 halves, and I'm going to integrate. So my answer still has x from the 1 plus, or really minus, 5 halves, the natural log of x plus 3, plus 5 halves times the natural log of x minus 3 plus c. And that's our answer. So this is where the long division comes in. The long division comes in anytime the numerator is bigger than the denominator, the degree, or the degrees are the same. You have to do long division first. Then you can do partial fractions. Again, it's long. You guys will get faster at this. Eventually we'll do some shortcuts where you don't have to do every single step. We can do some of the steps in our head. But a lot of it's just algebra because the antiderivative ends up being natural log for most of these. All right? So your homework is, this is assignment number 4. Today's going to be the 10th. If you need to watch this video again tomorrow, because you have to, or go longer on it, go ahead. Page 373. This is 7.5.1, and you're just doing 1 through 17 odd.